Testing.
Yeah. No, this one's on now.
Hello? Oh, fantastic. Okay, wow. Hello, everybody, and thank you very much for coming. Welcome to golang-syd. Thank you so much for making it here tonight. I know that we had quite a few obstacles in our way with the train strikes, with the teachers going on strike. There was nurses on strike as well. We didn't go on strike, though. We're still here. So thank you for making it. So just to give you a bit of a rundown in case any of you are new tonight to golang-syd. So we meet up regularly now after our big break with the big C word, COVID. So we've always had a long break. Back now. This is our second one back. We are still ironing out a few teething problems, as you have realised with the entrance tonight, which, by the way, I'm really sorry about, and it won't happen again. So also wanted to let you know that your organisers are myself, Cherie, and our new organiser is, a round of applause please, Tiffany. So if anyone is interested to get involved with golang-syd, whether you'd like to either do a talk or perhaps you'd like to sponsor, or maybe you might have some ideas. I know that tonight we have a little bit of an interactive spin-off, which we do like. We do like the interactive stuff. So any ideas you might have, then feel free to just scan through our QR codes. That's the best way to contact us, or if not, shoot through an email to any one of us there. And also would like to say a massive thank you to our sponsors for tonight. Of course, it's Microsoft as our first and favourite host for the venue for golang-syd, which we have got for the rest of the year. Thank you very much, Simon, for having us. And also thank you very much for WeMoney, who have covered the cost of the food and the drink for tonight, who Simon is the pioneer for tonight of taking care of that, who is the CTO of WeMoney here tonight, speaking for us as well. WeMoney's mission is to empower people to take control of their financial lives. If anyone would like to know more about WeMoney, please speak to Simon. And last but not least, PRA, we have to mention this because if we don't, we're going to get into trouble, but as you might know, PRA is the company that Tiff and I work for, which is a recruitment company. So we kind of have to tell you that. If you want to find a job, then speak to Tiff. If you want to grow your team, speak to me. Thank you. And the next one, speakers. Okay. We've got Simon Mittag, CTO of WeMoney, as mentioned before, who is going to be speaking to us about a lockdown project Jabba, spelt J8A, quite like that. And then we've also got Roman, who is speaking about he's actually done quite a lot of stuff with training people how to work with Go throughout the Mantle Group, which, if you haven't heard, the Mantle Group has got quite a few different companies that work underneath it, like Digio, Kasna, loads of places. But yeah, he's done some really good stuff with teaching people how to work with Go. We've got some really interesting stuff happening tonight. And also I'd like to say thank you very much for your donations, which are going to go to Indigitech. Indigitech, you know about Indigitech. Do you want to talk about it?
So Indigitech is a non-profit organization that aims to increase indigenous participation and success in tech. I asked around for indigenous like Golang developers, and they couldn't find me any. So that's something I want to fix. So like I said in the email, we did not become money-grabbing monsters. We just need that cover charge just to basically apply some prospect theory and some psychological manipulation to make sure that you come in and stay in. And that allows us to sort of manage the capacity of this venue, right? Yeah. So tonight's cover charges will all go to Indigitech.
Yeah, and also last month we managed to raise $600 to the Bunjalung community, who helped and are helping to look after the victims in Lismore. So thank you for raising that amount of money for last month as well. Okay, so lovely. Last but not least, our next meetup is going to be on Thursday, the 11th of August. Please pencil it in. Hopefully we don't have any train strikes or any other strikes. And we look forward to seeing you there. Okay, that's done. Very warm in here. Okay, I'm going to pass you over to Simon now. Thank you very much.
One last thing, don't forget, tweeting is mandatory. So the hashtag is golang-syd.
Like you.
Thank you very much. I'm going to
Yeah, do you want to take that?
Yeah, lovely.
All right.
There we go. All good, thank you.
Let me just
Okay, so this is the mic that you use. Oh, okay.
wire it up.
You wire it up, excellent.
Just try that.
Oh, no. Oh, okay, that's the screen.
Okay. Does that work? Shazam. No. Hang on, it's the wrong cable.
Wrong cable.
It's alright, it's going to work. It goes black first. Should do. Yeah. Ta-da.
Magic. Amazing. Welcome. Thank you, Katie. Thank you, Joey, Tiffany, PRA for organizing tonight. I wanted to give this talk for a long time. 2 years to be precise. So I'm really psyched to be here. I'm Simon. I'm CTO at WeMoney. I've been a Go developer for a little bit over 3 years, so not like super long. I worked in tech for quite a long time before that, using Java, using a variety of different languages, building different backend microservices type systems. I worked for BCG Digital Ventures for a while, where I helped build something called Boost in Malaysia. It's a microservices-based system that uses an Nginx reverse proxy in front. That grew from no users to about 4 million people using the app. So we broke a lot of stuff in that project, and so that informed some of what I'm going to present tonight. Worked on something else called OVO in Jakarta, Indonesia. Also grew very large. It's one of, I think it's Indonesia's latest unicorn. They have $1 billion business now, really big. Also microservices based. So I worked on like, distributed systems, a lot of high traffic web applications, digital apps and mobile apps with backend services, the way we build software today. I'm a big fan of open source. I have been for many years. I use lots of open source software every day. I couldn't do my job without open source, so I think contributing to projects is important. If you have a good idea and you want to put it on GitHub, you should go do it. Come here, talk about it. That's what I'm going to try to do tonight. I mentioned WeMoney. I work for WeMoney as CTO. We are a budgeting app. We help you monitor your finances so you can connect all your bank accounts to the WeMoney app. It'll tell you your net worth. It allows you to track your credit score. We use Golang in the backend very successfully. We also use Java, the project I'm presenting tonight, to farm traffic to our production systems. Yeah, the app's quite successful. We've got 130,000 users using it. We very recently were accredited for Australian Open Banking, something we're very excited about, in February, and it's literally about to come out in 1 or 2 weeks from now. We're still bug fixing a couple of things on that front, but that's something we're super excited about because now we've got an API way to integrate with bank accounts and aggregating that data. What is Java? Let me just take this out of my pocket. We start with a picture here. So we've got some upstream services. Yeah, you're writing an application, and chances are they're different languages. Some is written in Node, some is written in Java, because it talks to your enterprise system. On the left, you've got your clients. You've got your mobile browsers, and in between, you've got something else. And that something else receives your traffic and it routes that traffic to various upstream systems. It may also load balance that traffic to different upstream systems. So that's Java. It's a reverse proxy server. Yeah. It's been done before. It's clearly not a new idea. And next to routing, it also helps you terminate your TLS, or if you still want to use the term SSL, security at the network edge, if you so wish. You can also obviously still use it upstream. Java is written in Golang, no surprise. That's why I'm here. It's open source software, and yeah, it's my lockdown project. By the way, that is the March 2020 lockdown. That's when I started it. And yeah, I wanted to present that for a long time. It does get quite boring at home when you're locked down. I miss coming to do presentations like these. Used to do a lot of this stuff, and yeah, I'm glad you're all here. This question I get a lot. You did what? You wrote another web server. Jeez, why? Right, there's traffic. Nginx, of course, that's been here since like 2004. Kong, there's Amazon, they do a lot, API gateway. And now there's Java. Why? All right. The first thing I want to say about Java is it's specifically written for JSON APIs. So if you use Java, you probably have JSON APIs, which we will do, somewhere in your farm already. Yeah. It isn't a general purpose web server, so we're not here to serve HTML web pages. It does that, but it's not built for it. One of the things specific to JSON APIs, if you had a 400 or 500 error in your upstream service, and it's spilling its guts and prints a stack trace, that's not going to be proxied downstream. It's going to be wrapped in JSON in a generic error message and hide that output from the upstream service. That's a big deal, actually, to more apps than you think. For example, if you build clients on iOS and you have static classes compiled that mimic your JSON, if you suddenly get a string, it doesn't deal so well with that. So it's actually, it is quite good to have. We insert, Java believes in observability of traffic, so we insert correlation IDs into our requests. We add headers that you can use upstream to pass on to your services. You can also configure these. And it retries requests that are safe to do so, get options, etc. Not post, clearly, yeah, we don't want to create resources twice. But it's trying its best to be a good citizen for JSON APIs specifically. And by all means, I mean, it's not the only project of its kind, and if you want a mix of JSON and other services, please use Nginx. Yeah, I'm not saying this is the one software to solve it all, but this is specifically built for JSON. Next up, security. I spent a bit of time looking at SSL labs and how they rate endpoints. So if you run any APIs or if you run anything that uses TLS on the internet, and you haven't been to SSL labs, I really recommend that you do go there. They check the ciphers that are enabled in your server. They check the different protocol versions and for several types of attacks. So what we did is just disable all the old and badly rated ciphers, so you get an A+ rating out of the box, which is really good. That's what you want. And if you ever do a pen test, your pen test is probably going to ask you for something like that. Right. Java does JWT token validation, so you can configure it to check your signatures. I'll talk about that some more later. And yeah, because it's written in Go, it means we have this tiny binary, one file, no dependencies. And I still love that about Go. Every time I compile something, I've got one file. And this is from somebody who spent years writing apps on a JVM where you install the JVM, and then you have your penetration test, and then you have 257 CVEs that are listed against your application otherwise, that you're not responsible for because of those external dependencies. Next up, efficiency. Obviously, APIs, high traffic. I have a lot of numbers for performance that I'm not going to share tonight, but let me just say it can easily handle around 5K requests per second on a handful of connections. It can handle a lot more if you put enough hardware underneath it, which is, again, thanks to Go and Go's multi-core support. It has a relatively low memory footprint, and it has pretty good timeout controls that I'll talk about, where we disconnect clients on the internet when you no longer want them, which is really important when you build APIs. Cool. Lastly, I built it for everyone. Yeah. It's saying DevOps, it's for the people that run servers. That means you. Yeah. Everybody here builds software. That means everybody here runs software and runs servers on their desktop. I spent so much time writing friendly log messages and not playing with my kid that I can't honestly justify. Okay. But I wish when I read other people's logs that they thought of the person running the server when they write those logs, instead of printing stack trace into the log and letting someone work out why the program crashed. Okay, it's really important. I think Java is pretty easy to configure. It's a YAML config. You have only one environment variable to populate. I'll show you that. And it makes DevOps easier. Another thing that is pretty cool from a DevOps point of view is something I built about half a year ago is ACME. I say SSL, cert renewal, but I shouldn't because it's TLS. But what the server does is it allows you to renew your certificates while it's running. It's something Amazon does as well, but this server does it without paying for it. Okay. And lastly, it's got built-in application performance monitoring, so you don't need to run any probes next to the server. It logs pretty much all of the resource sets to its log file once a minute. So what we do is we connect Splunk to it and print that. And we haven't had to monitor anything on top of that. All right, that was a lot. That was a lot of claims. All right, let me get deeper on some of these and show you what's actually under the hood. Docker-friendly and configuration. Let's start with that. This is probably the simplest possible configuration I can think of. So what you got here is your YAML. You declare which port you want to listen on. No surprises, yeah, it's declarative. You have a HTTP listener. If you want to listen on TLS, you insert that. You define what's known as a route, which comes with a path and a resource. And you map the two together, and you're in business.
You've got double quotes in there twice, but nested double quotes. Does that actually work in a shell script?
It'll probably need better escaping in a shell script. Yeah, definitely. You can pull Java as a Docker image. You can install it with Homebrew. You're using a Docker image, and then you run it. Okay? I'll give you a quick tour of how that looks like. I figured I can't come to golang-syd and show you only PowerPoint. Yeah. All right. Can we see that? Okay. So here we've got a web server. That one's running in the top. It's listening on, I think, 60083. Here we've got Java. I'm going to shut it down real quick. And loading this config file is the config file I just showed you. And it's up. And down here we've got curl. And I'm going to hit that path that I just spoke about, which is going to get proxied all the way to the back. And there you are. One thing you may see, I'm not sure how well that's visible on the projector. You can kind of see it. Is that extra header, X request info. Generally, Java produces one log line per request because when you run a test with 100 million requests and you have more than one line per request, your log file is going to get really, really big, which is ugly. But you can enable trace level logging with this flag by passing that in for development purposes, and it'll tell you where it went upstream, how long it took, how many times it tried, and if it had to re-encode the response from upstream. All right. Let's put this back on full screen. Okay, so this was relatively simple, right? There's only a few parameters in there. On this website over here, I've got a full reference doc of everything you can configure. So there's timeouts clearly. I'll talk about these again in the latter part of the presentation.
It's a very short URL.
What's that?
You've got very short domain. How much did it cost?
$8.
Interesting.
It was free. Yeah, it wasn't much. IO was pretty good, was pretty easy to get. Path transformation, so you can rewrite your URLs, which is what most people want when it comes to managing upstream traffic. Routing policies, so you can do things like A/B distribution of traffic. You can send a certain percentage of your traffic to one server and the remainder somewhere else. Token validation, I already mentioned. You can redirect HTTP to TLS, which you probably want to in production. Oh yeah, and the proxies WebSockets. That also took a while to build. So from HTTP 1.1, you can upgrade to a WebSocket. You can keep that connection open. It's got that socket between your client and Java, and then has another socket upstream and pipe starter in both directions. Cool. So when you talk about what's possible, yeah, it's also important to talk about the design and what you want in and want out. So I wanted to share one or two things that I found helpful when it came to designing this piece of software. The configuration is YAML, right? YAML is declarative. Yeah? So that means Java's not going to try assume anything you didn't put in there. If you need HTTP, you need to give it the port. It will not default to anything. You want to declare in your config file what it is you want the server to do. It's self-validating, so when it starts, you can expect it to work. In fact, when I got a co-committer on, I drove him mad by writing something that changes the config, and there's a config panic method which shuts the server down when it's trying to come up, when it validates all sorts of edge cases. Because if it's not working, it shouldn't be up and sort of die, or give you, grayball you and serve you data that isn't good. It should just not work. Because it's YAML, there are no CLI flags, so you can't -X or -I or capital W override what the YAML config does. Because that would defeat the purpose of declarative configuration management, right? Okay. There's also no scripts to modify your request. So Kong, I think, excels in Lua scripts, and you can change requests, inserting headers, changing, payloads, etc. I don't think that's a good idea, because you're turning it into a heavyweight API gateway. I think it's the ThoughtWorks technology radar that, which I love, by the way. If you're not already subscribed to that, I really, really highly recommend that you do. That had an anti-pattern in one of the sections. It was called Overambitious API Gateway. Yeah, and that's what I don't want to be. Okay. It's very, very light. You don't want any business logic in here. So like scripts to modify your requests is how you start crashing your server. And there's no hot config reload. So once the server's up, it's there. Now I have to asterisk that because 1.5 years in, I started supporting ACME certificate renewal. You kind of have to reload some of your config. And again, the pain we went through to test that that doesn't crash is quite significant. In fact, if it does crash, it just doesn't swap it and tries again the next day. So let's talk about certificate renewal. I'm really a big fan of this feature. Have you seen this message? You probably have. This is Chrome. You're looking at an expired SSL certificate, as they're commonly known. So let's have a look at Google for something, expired SSL certificate. I'm using SSL again because it is so popular. And we're searching, not Google search, we're searching Google News. And so we've got Exchange down, GitHub down, Spotify down. That's all within 1 year because of expired certificates. Yeah. It's so common. It's one of those things, if I had $1 for every time that happened in my professional life, I'd be significantly richer than I'm now. It is very common. And why is that? It's because certificates are unreadable. Exhibit A, the certificate. Do you want to wake up and look at that? You probably don't. Yeah. And if you can't sleep, I really highly recommend RFC 5280. Yeah. You read a lot of these things when you build a server. X509 version 3, that's what we're looking at. It comes in PEM format, which you're probably familiar with. It's base 64 encoded, so that's not particularly difficult, but it's a DER certificate containing an ASN1 structure. That's the mouthful. If you are if you've ever used OpenSSL and dumped a certificate, you can look at that structure, common name, etc., different certificate properties. And there is a chain of these things that you have to get to work. 3, maybe 4. The certificate, intermediates, and the root certificate. There's no wonder this stuff doesn't work, right? And to top it all off, you have to change them only every 1 or 2 years, right? You're not going to tell me you're going to put that in a calendar and actually remember. Yeah. It ain't going to happen. All right, so what are we doing about this? The first thing, I said I like good log messages, so I wrote a very long log message. We're logging this once a day. What's the certificate for? When does it expire? In a way that people can understand. Is the certificate valid for longer than 13 months? I think it was 2020 or 2019, I can't remember. Apple and Google unilaterally decided to shorten the lifespan of certificates, so even perfectly good certificates that actually have a valid signature are not recognized by Chrome and Safari after the age of 13 months. So it's 398 days is what you want now. So even if you're like, you have no crypto errors because nothing crashed, you still may not be able to use the certificate. And yeah, so it says here, you may experience disruption here. Gives you a stat message, and that's how I started. It prints you the log file every day, and as you increase, as you approach the deadline, the log level increases, and it starts getting more annoying and help you. Then I figured, okay, health check is cool, but I'm not going to be able to make a difference with health check because it's just a log message, and people ain't going to read it either, right? So then I found out about ACME. Acme, it sounds like what's that, Wile E. Coyote. It stands for Automated Certificate Management Extension, okay?
On it.
Hey Siri.
Still working. Sorry. I'm having trouble with the connection.
Me too.
Please try again in a moment.
Love you, Siri. All right. So, Acme is a protocol and it's specified in RFC 8555. And specifically, there's something called Domain Verification Challenge. And I implemented this in the server. And what it does is 30 days after it reads your certificate and figures out it's about to expire in 30 days, it'll try renew it. Okay. How does that work? Well, you know the YAML config I showed you earlier. Just put this block in. You say it works with, so I should preface this, it works with one provider called Let's Encrypt, a big nonprofit in the US. They support free certificates. And you specify the domains you want that certificate for. Now, if you have multiple, all of these domains need to have valid DNS config. So the only prerequisite is that you need to actually run the server at that domain because it receives a callback on that domain. But other than that, that's all you have to do. You put that in there. You run the server, and it works. I promise.
When you do an initial certificate request with Let's Encrypt, it usually asks you to agree to the terms and conditions and get an email address.
That's correct.
Do you have those in your YAML file, or do you tell Let's Encrypt to make these?
It assumes default values for those, and just. But I should probably make that configurable. That's a good point. Yeah.
You said 30 days. Let's Encrypt certificates are only valid for 30 days. So what, you renew?
I get 90 days from them.
Yeah, 90 usually.
Yeah.
They recommend 30.
Another thing which probably should be configurable.
That often means you can only use that one server, right? Because you can't have two requests in the same domain.
Pardon me?
So if you can only have one instance of your API gateway running, because you can't have two competing for the same domain name.
If you had multiple running, you could have multiple DNS entries. It would probably just take you a little longer until the challenge is actually met. You're correct, though. It works better. In this instance, auto-renewal works better with one. Let me show you what actually happens. So server starts, generates a private key, so that's for the user registration with Let's Encrypt. It then registers the user using a default/dummy address, using your domain. So acme@yourdomain.com or something. I have to look it up. It generates the certificate signing request, sends it to Let's Encrypt. They read it, and then they call you back on that domain. And what Java does is it starts a HTTP listener just for that period of domain verification, leaves it up until the challenge response has been sent, and then shuts it back down. So you don't need to run HTTP for longer than necessary. Let's Encrypt then generates the certificate, and Java downloads it from Let's Encrypt. We then validate the certificate, not because we don't trust Let's Encrypt, right? But we don't trust anyone, because it could be corrupted, right? So we still have to go for that validation. And this is the cool part. We reload the TLS configuration of the server. Now, that actually took some significant work. I wasn't sure whether this was actually going to be possible using the net HTTP and TLS packages in Go, but it works beautifully. What happens is you load the TLS configuration again. All the existing connections that are open don't need the TLS configuration because their sockets are already established. And when the new TLS configuration starts working, we swap the pointer. And all new requests that come in just start using that. So the server is never down. Yeah, not even for a blip, which is really cool. And the good news is, sorry, I forgot this, but when you start, obviously, then we have to start listening for TLS. And I'm going to gray out, so you see this, the last step here, start listening in Bootstrap. That happens only the first time we start, but everything else happens on renewal as well. So we actually re-register the user, and we re-ask for the domain. So it's completely stateless. Yeah. This is not perfect. There's definitely, this feature needs a bit of work. For example, Let's Encrypt does have write limits. They're pretty high, but they still are. But if you were to run, a large amount of instances, like hundreds, I don't know why you would run hundreds of edge proxies, but if you did, you would hit that write limit, and they would stop serving the certificates. It is a free service after all, so they're not a paid provider. Let's Encrypt with Acme, so it's free certificates, free as in choice, not in beer, so you do make trade-offs for this, clearly. But you do get auto-renewal without restarting your server, so you have no downtime. You still have the health check in the backend. Cool. Next, I'm just checking how I go for time. I want to talk about timeouts and network resources, and then I'll tell you a little bit more about JWT as the remainder of the presentation. Cool. So why do I want to talk about network timeouts? Why does that matter, right? Have you seen these? I have. Lots. Spinners, bad gateway errors, gateway timeouts, this page isn't working. We're all waiting in front of our phones for the internet to catch up, right? It's mainly not the internet, actually. It's often dropped connections, badly configured timeouts, services that run too long on one end, or there's multiple hops and one of them just doesn't want to play ball. Let me take you through what happens inside a proxy. What does this thing actually do, right? So when a request comes in from a client, what happens on the server, what happens upstream, and what can go wrong? So the first thing, when you receive a request from downstream, so let's say an iPhone or Android phone hits the server, is TCP wait. So your operating system establishes a socket, and until that socket is established, you need to wait for TCP wait. The next thing is the TLS handshake. There's a couple of back and forth packages there until a secure connection is negotiated. Once that's happened, your server reads your headers. That comes first. That's not picture perfect with HTTP 2, but with HTTP 1.1 it is, because it reads from the top. So headers first, then body. And then once it's consumed your downstream request, it needs to repeat the same thing upstream. So we're waiting for a connection. That's usually faster because we're talking about a wired connection in the data center here. We perform a TLS handshake because all of you are using TLS everywhere in your data center, right? No one would deploy HTTP between servers, right? You wouldn't do that. I'm being facetious. We all have. It's not a good idea. So you want to use TLS, I'll show you. Zero trust architecture, by the way, sidebar, but if you have an interest in DevOps, read about zero trust architecture, smart endpoints and TLS everywhere. I think this started 10 years ago when a very well-known government agency started hacking a very well-known search engine, and they did that by getting into the data center and just siphoning all the traffic in the back of their network. And they thought they had a secure network, and they ran everything in HTTP in the backend. Very bad idea. Pardon me, I digress. So we're sending out the headers, we're sending the body, we're reading the response. The upstream request goes into idle timeout, that connection can be recycled, and we send the response downstream. That's what happens. After which the downstream connection goes into idle, okay? What happens upstream can happen multiple times. So if your first request didn't work for whatever reason, you can repeat that. So that may be a longer period. Okay, so that's the life cycle of the request. What does that mean in terms of timeouts? Downstream, there's a read timeout. That's the time it takes from establishing the socket until reading the whole request. I'll get to the default in a second, but this is often set to a slightly higher value, better so, because you're dealing with the internet, right? And I mean, if your phone is in Sydney connecting to your server, it's fine. But if it's in Katoomba behind the Explorers tree and going further and further and further, that network is going to deteriorate. And so you should still treat the internet as sort of sometimes available when it comes to the downstream side. Upstream, we've got socket timeout. That's very rare to be hit. I think as we set that at default to 3 seconds. If you can't contact an upstream server in 3 seconds in a data center, you've got a problem. Yeah, it's not the data center, it's something's up. Read timeout is how long your application needs upstream to respond. So if you've got a very expensive database query, that might take a long time, and you might want to set that to a significantly long time. Node, I think, sets this to 2 minutes per default. We do as well. And you might want to set it longer if you don't want your application to time out. And then round-trip timeout is the entire thing. So if anything goes wrong anywhere in the chain, that's what you want the upper ceiling to be. Idle timeout is how long on the upstream, how long to wait before a connection is recycled. So again, this is slightly different for HTTP 1.1 and HTTP 2. In 1.1, clearly we can't use the connection again before the request is finished because it doesn't know how to multiplex, but HTTP 2 does. And downstream is when the connection gets closed. So if you don't hear from the client after that time, the connection is hung up on. I printed timeouts here, the default timeouts, but you can configure all of these in the server to suit your needs. Okay, so now that you know how that works, what happens? What does Jabber do with the traffic? This is any random day in any of your businesses, yeah? There's a million phones trying to connect to your service and all trying to, competing for what's going on, and they try to connect to a small amount of upstream services. Okay, let's fire a round-trip timeout. So we don't know if upstream was at full, the downstream was at full, but we know it took too long. After 3 minutes, clearly nothing good is going to happen afterwards. All right. So what happens is the request context, the go context of the upstream request is being canceled. The resources for that are being freed, and the connections are recycled back into the connection pool. Okay. We now send a 504 gateway timeout response, and we drop the connection. We drop the connection both for HTTP 1.1 and for 2. And that's done differently than some other servers, but I believe that we're best served with any server error to hang up, because the client is probably wants to try again, and probably after some time. Right? There's no benefit in keeping these open. Next scenario, the client disconnects. Yeah, they've gone from the Explorers tree on the 6-foot track. They keep walking. The client is disconnecting. It's just doing something it shouldn't be doing. Again, this, by the way, this very simple mouse click here, this took an eternity to build, but when the client connection on the downstream disconnects, we event that upstream immediately and we hang up. Okay? So aborts the request context, recycles the connections. Again, that doesn't mean these connections are being closed, it just means they're made available for other requests. Okay? And we log 499, which is not actually a real HTTP code, but with something we borrowed from Nginx. They invented this code, which is clientable. Okay. So you control your API traffic with setting proper upstream and downstream timeouts. is one of the biggest reasons I actually built this server is I have better control over my traffic and my timeouts than with any other server I could find. And I have tried all of them. And you can rely on it to free up resources for you. Some numbers, yeah, this is obviously a subject that's scientific. So at our sort of entry-level load test with 5,000 requests, we add about 65 microseconds overhead per request doing all this. That's it. So that's the efficiency chapter. And now I want to tell you a little bit more about JWT and ML wrap. Okay. This is something you probably all do. Yeah, everyone that runs an API needs auth and needs JWT tokens. It's very common. What happens, you get a request in, it's got a token on it. The token has a signature, and it often has claims. In those claims, you've got properties you might want to check. So now you can make a decision whether to forward that request to your upstream service or whether to reject the request. JWT, there's a bunch of RFCs I need to throw at you again. 7519 is JWT, and 7518 is the different algorithms that are supported. There's a lot of them. HS256, so that's HMAC for secret keys. It's not very common, but it is very fast. So you can configure this if you have a shared secret that lives in your server and lives in your key generator. But not many people use it. Much more common is RSA, RS256, and ES256, as well as PS, but that's less common. Java does signature and claims verification, and you can attach the JWT configuration to each route. You can define a key and say, I want to check that. Okay. You can specify your key in PEM format, but you can also use JSON web keys, and it supports rotation of set keys. So if you are not happy with having a static key, you can host your key on a web server. Java will read it. When it changes, it will detect it and then start swapping it on. How does that work? You make this block, add it in. You can insert your key right in here if you want, or if it's a JSON web key, you supply the URL here and the key will be loaded. You specify the algorithm. I added that in after I read about a bug, or not a bug, it's a hack on JSON web keys that were proxied and swapped out. And they were substituted with keys that had no algorithm and that pass a certain framework every single time. So basically, someone found a way to hack a server by putting a nil, if you like, JSON web key behind it and then hacking into the front. It's very clever. So what it does is it reads this value and makes sure that whatever key you're loading is indeed a key of this type. Claims is an all concatenated list, so any of those claims present will pass, and if not one of these is met, it will reject your request. And we've got this skew seconds we also added for convenience. You'll find that often if you're running an external service like one of the many token minting services, Cognito and AWS is one of them, and there's others commercially available. The clocks on these systems may not be the same clock that you run, and if they're not, if they're only a couple of seconds off, your tokens might expire too soon, and basically a perfectly good token might not work. So you can define a skew, which is a period of forgiveness you insert, where the token will still validate. You add that block to your rod, and that's it. You're validating. Token validation is pretty cool. And yeah, anytime you touch anything with crypto in it, the crypto package name or in general, you want to make sure that it works fast enough and it doesn't consume an extraordinary amount of system resources. So I benchmarked this. HMAC is really, really fast. It's very uncommon, but it's also the fastest of all of them. RSA works quite nicely, 65 milliseconds, 64 milliseconds, sorry, what am I saying? Microseconds, on top of your processing cycle. As you go up in the key sizes, it gets slower until 1 millisecond range. And then ES is elliptic curve cryptography, and that's where it gets very, very slow. Right? I'm not a cryptographer, but I hear that that's mathematically very expensive. Do we have any cryptographers in the audience? There's one? Is that a show of hands? Or? No? All right. Yeah, Apple mandates ES cryptography for some of their services, but yeah, 12 milliseconds, I wouldn't add that to a request cycle just for running crypto verification. Cool. But generally, if you run a 48-bit RSA key, you're fine. It's fast enough. Cool. Some stats. Yeah, 2 years on and off. Runs Go 1.18. I'm not using any generics yet, but after last presentation, I might. So that was very, very good. Got very good test coverage. One thing let me share a few stories about building something like this. Sometime testing it, I noticed that there's only so far you can get with unit tests. Yeah, you can run your modules, but once you start running against the real servers, when you get real answers. So I started building an integration suite that tests against a running server, which gave me a lot better answers. Finally, I also built a completely separate performance testing suite. And I actually built a few smaller tools next to Java just to be able to do that, and just scaffold that whole pipeline to be able to develop this and run consistent numbers every time you build is quite challenging. First side project, MSC6, yeah, it's the chaos monkey of web servers. It's the worst web server ever built, I promise. Okay, so it does things like bad content length, garbled gzip responses. It'll crash in the middle of execution. It'll time out reading headers and sending headers, and it'll do everything wrong. Bad keys, you name it. Yeah. And yeah, with apologies to the community, it's also written in Golang. But you can't build a proxy server or any server without, on the boundary, having some other tool that covers for all your edge cases. It's not going to work with unit testing alone. But that's why we built that. I built this other tool called Pod. That's mainly for load testing. That's one of my most recent projects. It does it spins up a lot of parallel connections for HTTP 1 and HTTP 2. HTTP 2, obviously, as you may know, multiplexes, so it's not built to have many connections running. Once you've got a connection sitting to one server, it'll start multiplexing through it, so it does many HTTP 2 connections, and it gives real-time metrics to the user about how you're performing, which is very, very interesting, and is actually required to test this. Okay. Also stores its scientific numbers like setup, like RAM, etc. Tests your internet speed. It'll test the living daylights out of your environment before running performance tests. What's next? I need to work on HTTP 2. Definitely got a bit of work ahead of me. Upstream, I've currently got it disabled. Downstream, it works fine. We've got plans for a kube ingress controller because after working on this for a while, we found that a system like this doesn't live in isolation. You deal with people having existing tooling. Kubernetes is everywhere. Clearly, you can't ignore Kubernetes. So we looked at building an ingress controller. We're still in the early stages. If you have experience with this subject, by the way, I'd very much like to hear from you. That would be amazing. Okay. And yes, rely on community feedback, yeah, which is why I'm here. If you've got an idea for how to make this better, please do tell me. If you want to get involved, I got a website up with the reference doc. I mentioned this. I got an issue tracker. If you don't like something, please raise an issue, or better, make a pull request. I'd love to hear from you. And if you want to get involved, I'm absolutely looking for committers. I spent, as I said multiple times, 2 years, be careful there, building this. I got one other person to help me now, but it's at a point in time where I need many eyes and many hands on this project that would really, really help elevate it. And yeah, if anything else, if you want to give me a star, please do. I'm trying to get into Homebrew and grow our GitHub following. Thank you very much.
Questions, anyone? I've got one. What are your thoughts on the new trilogy?
On the new trilogy?
Yeah. You have a lot of Star Wars references.
That's a loaded question, yeah. I watched it. I'll answer your question after I showed it to my kid. I'm going to try solicit his answer first.
All right, so, yeah, Mike.
I had two. I can only remember one at the moment. Maybe it'll come to me. Very early on, you mentioned that you had a header, extra info header that you could send to get debug information in your logs. Can that be disabled server side so you don't have nasty clients just constantly adding that header to pollute your logs with debug info?
I'll tell you that I was actually wondering whether I should include that in a presentation so I can keep that a secret. But the answer is I should have, but I don't. And,
Okay, no,
yeah.
all good, all good.
It's a PR waiting to happen, absolutely, because you could spam the log files.
I'll
with
have a
trace
look
level
tomorrow.
info.
I'll send you a
Yeah,
PR.
totally.
Yeah.
Please.
Other one was to do with Kubernetes ingress controller. Are you looking at like being able to have multiple instances running in multiple pods and okay, so you're going to have shared config somewhere?
Yes, there's a very famous Star Wars robot that I'm not going to name now, but he's golden, and he masters many forms of communication. We sort of wanted to name that project after him and be the central point of real-time configuration. It's going to change the nature of this because it's no longer static config, but you would, and absolutely that would be a fork.
Yeah, cool. I'm not sure, but I think there is actually I'm a bit rusty on Kubernetes, but I think there's actually a sanctioned way of storing YAML files within the actual cluster configs.
There's Helm and there's tooling out there that supports this. Obviously, if you start building one of those integrations, then you have to start building them all because otherwise you to work only with one part of the ecosystem. So it's in the design stage, yeah.
Cool. I will look at it and hopefully send you some PRs.
We've got a question over there.
Oh.
Hey, thanks for the presentation. So, yeah, that was cool. Yeah, my question is around the limitation for transactions per second that you have over there for 5,000 requests a second actually. Is that a hard limit or it was just a test?
Look, putting performance numbers in PowerPoint is treacherous, right? This doesn't mean anything unless you know how much computer hardware you had on either side, plus whether it ran on the same host, plus a lot of variables. I ran up to 50,000 requests on 65,000 connections that we managed, and that's actually one area where I managed to beat Nginx, not in speed, but Java ran all the connections without killing any, where Nginx started around the 50,000 mark, it started to hang up on the connections. It's a lot faster than 5,000. When I started building this, I thought RPS, requests per second, is the metric I want. After some time with the project, I actually figured out that active connections and memory consumption for each connection is much more important than requests per second. But they're both important.
Yeah, thanks.
Oh. Julie? No drink driving. You had beer.
Just wondering if you consider caching for GET requests and rate limiting.
Great questions. So I'll repeat the question. Is it, did I consider caching for GET requests and rate limiting? I did consider caching, but decided not to implement it. But if you think it's valid, I'd love to hear from you. The reason I didn't is because it's a proxy server, and if I start getting too smart about caching, that means I deprive upstream of traffic, and it's for API. So most of the time, it's a web server concept as opposed to an API server, JSON API server concept. The second part, rate limiting, I'm working on that.
Any more questions, anybody? Yeah. Oh, I'll go this way if that's okay first, sorry.
Did you have any issues with WebSockets and certificate changes?
I haven't done security for WebSockets yet.
Okay.
So
and did you write it all without any external dependencies in Go? So it was just straight up Go libraries, no other people?
Oh, there's plenty of dependencies in it. Please look at the Go mod file. Okay. Yeah, I could not build all of this from scratch. Absolutely not. No. So Go standard library, the JWT is a framework, WebSockets is a framework. There are many forks as well. I was asked earlier, the gentleman left. I forked something that I should probably not have forked. So there's plenty of external dependencies, and yeah.
Cool, I'll have a look, thanks.
Anyone else? Oh, yeah.
Thank you. I want to continue ask on configuration. So in production usage, after you start running and you need to add new endpoints, so what's your strategy to, what's your availability time? You need to restart it? Or?
It's a great question. What do you do if your static configuration changes at runtime in production, right? So the good news is that there's lots of tooling outside of something like Java already. So for example, if you deploy your new configuration with your +1 service in Kubernetes, you could do that in a second deployment, and then you could swap it out, or you could deploy it on a second server and change the DNS. I haven't built anything into the service because in the end, the trade-off is that the declarative final config is more important to us than the hard swapping.
One more question about existing connections. Do you, your existing connections with your old services, would you restart all client connections when you introduce a new endpoint?
I'm not sure I understand the question, but maybe talk to me afterwards, all right? Thank you.
Anyone else?
Oh. Yeah, sorry, another question just came up to my mind now. There is a concept of blue-green deployments, I think, if I'm not mistaken, like where you prepare a canary image, and then you can forward like 1% of the requests into this new image, and then you go progressively rolling out until 100%. Is there a way to do that with this API gateway, or that's completely unrelated to that?
Not yet. I had a previous version of this whole thing written in Java a couple of years ago, where we had that blue-green deployment specifically to phase in new services. To do that, we would have to develop a domain model for upstream services. Right now, they're just URL resources, but there's no grouping. Also, we're getting into Kubernetes territory here. So if we were to become an ingress controller, Kubernetes could solve this problem for us.
Yeah, on the subject of not sort of like stepping on other like things that you might integrate with, you mentioned that you have path translation. Is that like really simple substitution, or do you have like a regular expression language or like sort of?
It's very, very simple. I use compile regexes inside the server to do it, but it's very, very simple path append and path rewrite from a common stem.
All right, cool.
It's not super powerful, but it's very robust.
Okay. Was that based on previous work? Did you copy sort of the way Caddy does it or Nginx does it or anything like that?
No,
or?
I just wrote it.
So it's yeah, all right, cool. Yeah. Oh, all good. I'll talk to you afterwards.
Anyone else have questions? No? All right. So,
true.
And that's why you shouldn't one wheel when you're when you're talking. So anyway, thank you, Simon. And what we're going to do next is we're going to have a small break, and then we'll come back with Roman's talk, and it's quite interesting. Thank you, Simon. All right, so go socialize, have, I guess, more pizza, more drinks, yeah. And we'll be back in about 5 minutes.
Thanks for the presentation.
Thanks for coming.
What would you say?
Cheers. I went way too long, by the way. I'm sorry.
Like if I'm starting up a new project, what would you say like is the biggest advantage to use your
Testing, testing. Cool. All right. So our next speaker is going to teach us to write fearless concurrent code. And I'd like to present Roman.
Thank you very much.
Right. So you gave me a GitHub link. There's a lot of things in it. Are you going to go through all of it?
Hopefully.
All right.
We'll need to get moving.
Okay, cool. We'll need to get moving then. Let's go.
All right. And because we are in a hurry, I will apologize in advance. I'm going to go over the slides really, really quickly. So all the introductions and all those things, I'm going to pass them through really, really quickly. So let's start with some introductions and what we are going to talk about. Table of contents, introduction. What are the goals of this talk? And then basically we're doing some demos, and it will be some kind of interactive. I'll ask you for a couple of questions and we'll see how it goes. So I have 7 examples of Golang concurrency and we'll go over them. All right. Some things that I like to do, again, I'll go over them really, really quickly. It doesn't matter, it's not really important to you, but let's go, continue. A little bit about my professional background. I started my career at Intel in Israel. I came here 4 years ago. Mostly low-level C and C++ and assembly. Later, I worked at JFrog, where I first exposed to Golang, and the JFrog CLI was written in Golang and other integrations as well, and tools. And today, I'm working at Digio, part of the Mental group, and part of being in that group, I'm running the Golang training, which few of my graduates are here. And basically this talk is part of that training. So I took a few examples that we are going over and I'm going to show them to you. Yes, so back to the topic. If I would ask you a simple question, if you would go to somebody in the streets or in the pub and you would ask them, hey, why do you like Go so much? What would they tell you? Go away. That would be probably the right answer, because what is Go? But if I ask it here, what would you say? Probably it's really simple, it's easy to learn, and one of the most important aspects of Go. And the first actually item when you search for why Go is good, basically this is the result. It is built for concurrency. It's easy, it's simple-ish, but it's not without pitfalls. So if you want, you know the Spider-Man famous sentence or saying about great power and blah, blah, blah. I'm not going to say it. I'm going to say if you have something similar, if you have a powerful gun or a weapon, try not to shoot yourself in the foot. And this is exactly what I'm going to present here. Show a few examples of how to avoid those kind of common mistakes and what you should think about when you're writing concurrent Go. So, the 3 questions that I would ask you in the following demo, in the following examples, is first of all, did we get the expected result? It's a very, very basic question. Yeah, you want to do something, you expect the right result. Second question, do we have any race conditions? This is a little bit more difficult to understand what is a race condition, how we detect them, and I'll show how we can easily, or not easily, but a tool that would help us detect those. The third one is, did we handle all the errors? And if there is a shutdown, for example, if there is a fatal error, did we handle them correctly and shut down our process or our application gracefully? And it's really, really important if you are working on a very, very high sensitive component, which in a result, if it shuts down, you need to record. You need to do a graceful shutdown in order to preserve data or information, or even to log it that there was an error. And that pretty much sums all my slides. So that's pretty quick. And now we are moving to the demo themselves. All right. So this is the demo. It's pretty much IntelliJ did some interesting things with readmes. And the demo, I'll start and go to the actual first example. I'll explain what it is, and it will be basically a template that we will build on top, and each example will be a little bit more complex, a little bit more interesting. I wouldn't say it's simple, I would say it's basic. So, what are we doing here? We have a very, very simple function, and that function would create a golang. We'll invoke a go function, a concurrent go function. And the goal here is to count things. It's very, very basic. We will count, in this instance, up to 1,000. And I want to show you what exactly is the simple counter interface here, or implementation. So it is a very, very simple counter. We have two methods. The first one is the increment method. The second one is the count, which will return the current count. No locks. That's the point. Cool. Any questions? Look simple enough? Basic? All right, let's go back to the example itself. So in this example, we're just going to create a simple counter. We're going to invoke a go method, a go function, that would count till 1,000 and return the result. Cool. And the three questions that I would ask you are, do you expect to get the right result? No. Do we have any race conditions? So, what is the correct result? We are trying to count till 1,000. Okay? Okay, so the correct result of somebody who would write something like this is 1,000. I would expect this to finish up correctly and return 1,000. Nope. Absolutely not, and it's a very basic example, and it's good. Huh? Then you have the correct answer. Maybe. Could be, depends. Cool, okay, so let's run it and see that the expected result is not what we get here.
Wait, of course it's going to return 0 again.
We will get 0 because the go function is never invoked or never ran, because the main thread will basically kill it before it even get the chance to start it. And let's introduce the second test, or an interesting flag that we will test with. We are going to use the race detection flag. And what is it? If you haven't used it before, it's basically a built-in flag in Go that would allow us to run those race data detection feature that would detect any race conditions in your code. But it comes with a few caveats. First of all, if you are not hitting the exact scenario, it's not a static analysis, it's a runtime detection. So if you are not going to hit that specific scenario or test, it won't detect it. It won't detect the race condition. The second caveat is the runtime overhead and the memory overhead. So as you can see here as in the figures, memory usage will increase by 5 to 10x, and runtime execution to always, in the worst case, 20x. And so even though you can use them even in your actual run, you can run them with the -race flag, I wouldn't recommend that. But I would recommend running tests, especially if you have Go function implementation, you're implementing concurrency. All right, so we already saw that we're not going to get the correct result. And let's run the second test and see what happens here. All right, so we see here that we have race condition. We have detected a race condition. And can we tell where it is? Exactly, nice. All right, so the race condition, it's not only showing that there is a race condition, it actually shows you the line in which you have that race condition, so it makes it simple and easy to understand and fix what happened. So let's go over the solution. This is the first basic example. All right, so problem here, there is no correct result. We are not getting the correct result. We do have race conditions, and we're not handling any errors inside of a Go function or shutting down gracefully. Cool. Questions? Comments?
Can you try running Go Max 1?
Not at the moment. We don't have time, sorry. Yes?
How reliable is that dash race?
So again, if you are not writing the correct test, you won't see it won't detect your race condition.
So it's based on the unit test?
It based on what you are actually running. If you are never going to hit that scenario, you won't see that error. Yes?
If you add the parallel tests to all of your unit tests and run all of your unit tests in parallel, which will increase the chance of the race flag erroring if you do have like concurrent resource usage.
That's true, yeah. And it will make them a lot more complex to understand what happened, especially if you're not cleaning the state correctly.
TLA plus is out of the question. TLA plus is out of the question.
TLA plus?
It's a language to formally prove that your program is correct.
All right.
On ego.
Okay, that's interesting. All right, let's go to the next example, or let's try to fix things up a little bit. So let's try fixing this example by, instead of just passing or ignoring the Go function, let's use the wait group to actually stop and wait until we get the actual result from the counting and then return the value. So we're using the built-in sync package, and I suggest everyone to go and look in the sync package. There are a lot of utilities there that are very, very useful and very, very interesting. I'm going to show and speak of only a few of them, but it's really, really interesting to read what they have there. Cool, so the way group behaves in the following manner: you add a number or how many executions you are going to run before you start the Go function. And you need to indicate that the Go function has finished after the Go function has actually is done. So we will use the defer instruction here to indicate that this execution has been completed, and we are going to wait here until it's done and get the result. So, question, the same questions again. Do you think we will get the right result this time? No. Yes or no? Who thinks yes? Who thinks no? All right.
Your loop is actually the loop is no, this will get it right answer. Yeah, this will get it right answer.
All right, let's check it out. Okay, so we did get the correct answer this time. And the reason is that we are going to wait here until the Go function is done, and we are done counting up to 1,000, and then we will return the value, which is correct. Second question, do we have any data race?
What was the question?
Do we have any race conditions? Yes. Who thinks yes? Who thinks no? All right, let's try to see. No race conditions. And why is that?
The loop is wrapped in the Go function.
Exactly. Even though we're not locking anything yet, we're separating the execution. So first we're going to count, and then we use that result. So there is no need to lock anything, and there is no race conditions yet. Yes?
Wouldn't C.dot
Yeah, but it's a single Go function. A single thread that will loop 1,000 times. You have two threads right now? You have the main thread, right, which invokes the Go function, and the second thread that counts. Now, this is a very simple example, but it could be a very complex thing that runs in the background. Any other questions? Cool. So I'm going back to the original question. Do we have any race conditions?
Sorry, can I ask, okay, if you move the diff after the follows, would it have the same outcome?
Where do you want me to move this?
Yeah, if you want to put that after the fall,
After. It depends. If I'm using the defer, it doesn't matter much. If I remove the defer, in this case, it won't matter much. In some cases, it will. So it's best to use defer. That will be the safest choice.
Yeah, but I mean, if you were doing exactly the same way you're doing that, but after the fall.
Yeah, same way. Same answer, yes. All right, let's see. And the third question, are we handling errors in any way or shutdowns? No, but I'll leave it as a question mark for now. And this is a small issue bug. All right, so we have the correct results. We don't have any race conditions. And the error handling or graceful shutdown is still a question mark because we don't know yet. Next example, let's make things a little bit more interesting. So in this example, instead of creating a single Go function, we will create 1,000 Go functions, and each of them will increment the counter by 1. So, yes. What would be the answer to? Will we get the correct result? Who thinks yes? All right. Who thinks no? All right. Let's see the result. There is a slight bug here. One second. Oh, let's run it from here. All right. So what happened? Exactly. All right. So what happened here? We have 1,000 threads running concurrently, but the counter is not protected. The counter, exactly, but wait. Basically, we have a read-write data race. We're reading a value which is not correct anymore, then incrementing by 1 and setting that value again, and it creates unsafe store. So if I would run the race condition detection, we will immediately see that there is a data race condition here. Yes. We got the 1,000 this time, but this is because the race condition adds a lot of overhead and behaves differently. But we do have the race condition.
Your ink is just a plus, right?
Yes.
That's interesting.
If we're going to the, it's just
Oh,
plus
you're
plus.
returning as a counter. Okay. Yep. If you don't return as a counter, I think the assembly would just use a instruction that increments so you get the correct answer, despite having a
Plus plus is not atomic.
Yeah, I know it's not something I know. But I'm just talking about the internal stuff. Sorry.
Yes.
There is line 13 fall.
Is it line?
So this is just readmes. The code is actually elsewhere. I'm hacking here. All right, so original question. Did we get the correct result? No. Do we have any race conditions? Of course. Did we handle shutdowns? Maybe yes, maybe no, we don't know yet. All right. So those are the results. Let's try to fix this a little bit and see how we fix this by using mutex and locking those increments. So in this example, I'm going to fix it a little bit. And we will use, again, the mutex struct from the sync package. It works really simply. You lock and release, and during that atomic period, it will increment the counter only once, and we will try to avoid the race conditions. So I'm locking. Again, we still have the 1,000 threads. I'm locking, unlocking, incrementing. What do you think the result would be now? Do we get the right result? Yes. Do we have any race conditions?
This would be exactly the same as if we ran it all single process.
Probably, yes. All right, so we got the right result this time, 1,000. And if we run the race condition, we also see that this time it's correct and right. Did we handle the shutdowns? We'll see. All right, this is good. Now let's try to clean the code a little bit. So I'll introduce a safe counter, and we will use the safe counter in the next examples. I want to clean the code a little bit. So the safe example, the safe counter, we'll use read-write mutex. When we want to increment the counter, we will use the write lock. When we want to read the count, we will use the read lock. And that would allow us to be a little bit more concurrent. So you will be able to read multiple times. Still, writing is only permitted to one thread at a time. Any questions, comments so far? All right. So instead of using the simple counter, the next example, we are changing it, and we are going to use the safe counter. And therefore, we don't need to lock anything, again, in our code. And just simplify everything. Cool, so the results remain the same. Everything is still locked and runs as expected. Any questions before we move to the next topic? Nice. Next example. Next example, we are going to talk a little bit about a different type of Go functions. Those will be long-term, long-running examples that will just do some work in the background and never stop. Now this is just a representation. What we are going to do here, I'm just going to continuously increment the simple counter that we have, and basically it will never stop. It will continue to work until something happens. For example, I'll press the Control-C and try to shut down the program. And this exactly relates to the third question. Did we shut down correctly? So, in this example, there is no more 1,000. We're going to continuously run and increment. And what I'm adding here is just inline print. So we will actually see that it runs and increments on the screen here. And what I'll do is, every time I run the test, I'll click Control-C and see what happens. So let's start with the first test. So we see the test runs, click Control-C, and we get failure. So the test didn't shut down correctly, or our program didn't shut down correctly. We are just abruptly fail and stop everything. We have no opportunity to clean after any data. We don't have an opportunity to handle any errors. It will just abruptly stop. Is this the desired state? Is this something that you want to see in your program? Maybe. All right. So, but do we get the right result?
What's the result?
The result is just counting.
Yes.
Do we get any result? Did we get any result in this case? I want to stop and get an actual counter. No. The test which ran didn't result in anything. It failed. So we don't get the right result. Any race conditions? No race conditions. We took care of them with the safe counter. Yes?
That's probably a silly question, but if we increment C here, and even if we don't return it, have we modified the underlying structure? So if we try to access it again somewhere else and we had basically shut this down, would it have been incremented?
Yes. So it's very simple. Print, and it just rewinds the cursor and print again.
Something to set it out, right? Which is a race condition. Where you have multiple. Oh no, sorry, it's a single. Yeah, okay, never mind. There's no reason. Okay.
Yeah.
If you go inline print, then there will be music.
Absolutely. We wouldn't know where like the source of that print came from, or the order. Cool. Let's run the race condition just for fun, and we will try to click Control C. We see it still failed. We don't have any race detection capabilities in this case. Fails. All right, let's go to the solution. So, as we said, we don't have the correct result. We didn't get any result. We didn't handle any errors and gracefully shut it down. So that's not good. Let's try to fix it. Next example. All right. So this example is a little bit more complex. We're going to use, there are various options of how to detect shutdown. It could be with your context, it could be with something else. In this example, I'm trying to shut down using Control C, and that's why I'm going to trap those interrupts and shut them down gracefully. So what I'm doing here, I'm creating a signal, a channel, which will trap, interrupt, and terminate signals. And I'm going to wait for those signals here using a basic channel that would read and unblock when I'll get that interrupt. When I'll get that interrupt, the code will continue from there, and that would mean that we are still in the life cycle of the program. It won't abruptly shut down, and we will see the result. So let's try the first one. Let's try to run this and see what happens. It's running, pressing Control C, and in this case, we see the result of that test. We see that we actually return value, even though it's not 1,000, but it is what we intended to return, and the test finished correctly. Yes? There is only one additional thread at this point, so we invoke only one Go function. See here? Yes?
So we're adding in the for loop, then when we get to the return, so once we get the signal response, it will return, which shuts down the non-stop code keyword shutdown function, and that tilts the subcode keyword, so identify the result.
Yes. And the next question, did we shut down correctly? Do you think it's a correct shutdown? False. And why is that?
Because the defer didn't get run. Your defer function is itself a Go routine which did not get run.
Yes, that means that the Go function is not being shut down gracefully. We do shut down gracefully the main thread, but not the Go function. So there are still...
It doesn't know how to return.
That's right. At this point, no. Yes?
So the deferred function doesn't get called at all, or is there race condition?
It doesn't get called because the main thread would just kill that Go function. Yes.
You should also try to say quit. Just
Next,
FYI.
next time. Cool. Do we have any race conditions? Probably not. We're still using the safe counter. Shouldn't be any race conditions, even though the Go function doesn't shut down correctly. There is still a lock between the increment and the count, and therefore shouldn't be any race conditions. Let's just make sure, check it out. No race conditions. I'm shutting this down and still graceful shutdown, sort of, and no race conditions. Cool. Solution. Did we get the right result? Yes, we did, sort of. Do we have any race conditions? No. And did we handle the shutdown gracefully? Still no, but so close, so close. Cool, let's try to fix it up. Let's try to fix it up. So, how do we fix it? Instead of waiting for that signal to happen outside, we will move the signal inside, and in this case, we will use the select instruction. So, in the default, if we don't get the signal, we'll continue to increment the counter. But if we get that signal, we will gracefully shut down this Go function, and then we are going to, of course, add a waiting group that would wait for that Go function to finish up gracefully and return. Any questions about this? Yes?
You said when you did Control-C, you said that Go would kill the subroutine. So how does listening for the signal change the result?
So we are listening to the signal. Control-C would be basically invoke, will send the signal to this channel.
Right.
It will notify us that we received Control-C.
So instead of killing the subroutine, it will send the signal.
Yes.
Oh, I see.
And then we are waiting for that signal to arrive here. And once it's there, we're returning, we're closing, we're shutting down the Go function. And then the first defer would say, we gracefully shut that function down. And then the second one would say, this thread has been completed and done, the waiting group. And here, because we are waiting on that waiting group, the Go function would be complete, die, and gracefully shut down.
If you move inline print down one line, it will be faster.
If I'll move what?
If you move the inline prints down one line, below the brace, it will be faster. It will perform much faster.
Possibly. We can do benchmarks later.
Only one thread, but
Cool. All right, so let's check it out. Control-C, gracefully shut down. And is it true? True. Do we have any race conditions? Two. All right, so let's just run this query very quickly. We don't have any race conditions. And let's go to the results. As you would expect, everything behaves as expected, and you see a harmony of cars and threads running together in a nice way. Now, I do have a bonus question. So I'm going to make a small, tiny change to this code, and I want you to, I will ask those questions again. So I'm making really, really tiny change. I'm swapping 2 commands. And the question is, what will happen now? So let's start with the first question.
Yeah, it depends on how far you get between the wg.wait and the printf statement. There is a time that there is a race condition that is not an access kind of race condition. It's a function.
Okay, so I'll ask the question again. Do we have any, are we going to get the correct result? Yes. Second question, do we have any race conditions?
Not an access-based race condition.
Yes or no? Who says yes? Who says no? Cool. And the last one, graceful shutdown or not? Might. What does it tell you? What does it tell you? Probably says that there is a race condition. It probably says that there is a race condition. All right. So let's start by writing the example. Let's stop it and see what happens. It says we got the right result, and it's gracefully shut down. But if we run this with the race detection flag and stop it now, we have a race condition here. But the race condition is actually on the graceful shutdown flag, on this variable. Exactly, between the write and the read. Yes, exactly. Because the done will be invoked first. This lock here will be unblocked. And then you have a race conditions between the setting the graceful shutdown to be true versus the print here. Cool. And you have a crush. And this is it. I'm on time. Any questions?
All right. Let's go. You get zapped again.
Zip.
All right. Questions, people. Well, I did my fair share of heckling, but it's now your turn. Questions? Oh. I'll go to you then. I'll go to Andrew next.
Do you have any experience with coroutines with Lua?
Coroutines with?
Lua.
Lua?
Yeah.
No, I don't.
Okay. That's actually where I was introduced to this whole concept of routines, was Lua. So does anyone in here have any experience with the two? I'm wondering if there's similarities between them. I assume so. It's very much like
I know that they are very similar in Kotlin.
Yeah.
So they're the same lightweight threads. Yeah.
Okay.
I'm not sure what Lua is.
It's definitely not like Java.
Yeah. Can I go to Andrew and then come back to you?
Just to maybe simplify it, if you consider using atomic int,
I could have.
lock and unlock.
I could have.
Might have just made the examples look a bit simpler.
Yeah, exactly. We still want to show something, so using atomic would defeat the purpose of this presentation, let's
I
say.
think that's just the same as using lock and unlock around the...
Actually, it is, but you'll still need to lock the read.
That's also probably faster a bit. Yeah.
Ooh, oh, I know I've got that one, but oh, same questions. So have you tried this where you because you're incrementing and addition is an associative and commutative operation, so you have multiple channels going into an accumulator which is itself multi-threaded, and then populate essentially you're doing your serialization process manually, where you take in the channel of multiple values and absorb as many as you can and then write to the counter. Have you tried that?
Basically, you're telling, is it something like producer-consumer pattern?
Yeah.
Very similar, yeah. Yes, I do have other examples, and we are going over in the training over consumer-producer patterns, and we are talking about them, and we're talking about channels as well, and there are plenty more examples where those came from. Yes, we do cover them in our training. In this talk, of course not.
Maybe you should talk more about your training. And yeah, if you do cover rings in your training, you know.
Just slightly related to Andrew's question that we're talking about atomics. Have you considered doing like a sequel to this that talks about the pitfalls and advantages of using atomics?
Not really. It could be interesting topic.
Yeah, I've found it to be.
Yeah, definitely.
It's a Bigfoot gun.
I would even say the sync package contains lots and lots and lots of interesting utilities. For example, once.
Yeah.
It's a really, really useful thing to use. There is pool. There are other utilities that, like atomic, like functions, that are very, very useful, very, very interesting. I would encourage everybody to just dive into that sync package and explore it.
Anyone else? Questions? No? Well, you should tell us about the training and what's it called? DGO?
DGO.
Yeah.
So basically, I'll do it really, really quickly. Basically, we are running an internal training, Golang training, for whoever wants to be involved in that. The training is it's not simple, it's quite advanced. So this is one of the last topics that we are talking about, concurrency. We are starting really, really basic and evolving a real project like production, like training. And it goes for 10 weeks in total. We have few graduates here that can speak how hard or easy it is, but the engagement is great. And I feel like people who actually do that training are capable of going into our clients and working with Go really, really easily. We might offer this training externally as well. At the moment we are not, but we might in the future if there is a requirement and people interest, yes.
All right. So, thank you, Roman. After this, we're going to go to a bar downstairs in York Lane. I know how to get there. I don't know how to describe to get there. So I'll let Katie do it.
So, yeah, so there's a place called York Lane, which is a bit of a hidden gem. It's really hard to find. It's like in an alleyway opposite Made in Italy. Licensed for up to 30 people. That's the size that we're talking here. If anyone fancies joining us, we've got the whole place to ourselves. So,
for the YouTube stream, thank you for attending.
yeah, and just want to say a massive thank you to our speakers for speaking tonight. I'm sorry we didn't have more people to hear your awesome talks, but thank you so much to you guys for listening and for What are you pointing at? Like this? Am I speaking to the camera? Are we on TV? Do I say thank you for listening? Thank you for listening. Thank you. Yeah. Yes. Thank you very much.